Okay, so we're going to start a mini unit. This is only going to be 3 lessons for this. This is kind of one of those topics that, it doesn't warrant a whole chapter. But it needs to be taught. So we're going to talk today about binomial expansion. All right. And this is going to lead into binomial theorem. So you'll have today's binomial expansion. Tomorrow there will be a short lesson over something that you need for the binomial theorem, and then we'll talk about the binomial theorem. So binomial expansion takes the idea of a binomial, right? A plus b squared, right? So the binomial is the idea that we have 2 terms. You'll notice we have an a and we have a b. Okay, that's what makes it binomial. Okay, it has absolutely nothing to do with the exponent. The exponent can be anything, all right? And that's the whole idea, is that we're going to talk about if we have a binomial raised to any power, how we can find out what that equation or expression will be. So we need to look at patterns, though. This is very important to see the patterns. So if we have a plus b squared, okay, we know that that is a squared plus 2ab plus b squared, right? So we're going to look at the pattern if we were to have the rest of them. Now, most of these you could calculate. They would take very, very long. So I'm just going to actually write the formulas down. So if we had a plus b to the third, okay, which would be a plus b times this whole thing that we just figured out, the a squared plus 2ab plus b squared, and you'd have to use your expansion techniques to do that. So, but the actual equation for that, then, once we expand the whole thing, is a to the third plus 3a squared b plus 3ab squared plus b to the third. So this is if we were to take a plus b to the third, which is the same thing as, let me write this just on the side here really quick so we can see what we're looking at. A plus b times a plus b times a plus b. I want you to understand what's going on here so that we can see, so we understand why we're getting the answers we're getting. They get longer the higher the exponent, right? So let's also look at a plus b to the fourth. Okay, again, that's a plus b times a plus b times a plus b times a plus b. So the equation here then is a to the fourth plus 4 a to the third b plus 6 a squared b squared plus 4 a b to the third plus b to the fourth. So do me a favor for a moment and let's look at patterns. Let's look first of all at the powers. You will notice when ab squared, it starts with the a squared and then a to the first power. Okay? And in the second term we introduce the b, and it's b to the first power and then b to the second power. Now let's look at it with a to the third, or with a plus b to the third power. A to the third, then a squared, then just a. So notice how the powers go down. So we start with the third, second, first on the a. And then the b is introduced in the second term to the first power, okay? And then to the second power, and then to the third. Okay? Look also on the last one. We go 4, 3, 2, 1. Okay? And then actually, if you want to get into it, this is a to the 0, right? So, and if you want to talk about the b's, it would be b to the 0, b to the 1, b squared, b to the third, b to the fourth. All right? So if you were given something to a power, you should be able to write out all of the a's and b's, okay, just by following the pattern. Now, the coefficients, or the numbers that fall in front of each term, are a little different. All right? So we need to there's something that's called Pascal's triangle. All right? And I hope you have done Pascal's triangle before. If you haven't, we're not going to get into a whole lot of details of what it is and why it works, but I want to talk about, we need to look at patterns here for a second. I'm going to erase this. We're going to go backwards for just a moment. So a plus b to the first power is a plus b, and a plus b to the 0 power is 1. All right, now Pascal's triangle starts with a 1, and it is actually a triangle. So I can get my I don't want to lose what I have here. Okay, so it starts with a 1. Okay, then it writes down right underneath it. So this is when the exponent, we're going to call the exponent n. Okay? So when n equals 0, we start with 1. Then the next part of the triangle, when n equals 1, we have 1, 1. Okay? So on every part of our triangle, the 1s are going to be on the outside. So when we have n equals 2, okay, it's going to be 1, 1. Now, to get the interior terms, we need to look at, we're going to add. We're going to add, what is 1 plus 1? Okay, that is 2. All right? So we're going to keep going here. I'm going to go down to 5, just so we can see the whole thing, and then I'll bring it back to the binomials. So n equals 3 is 1, okay, and 1. Now we're going to add terms to get our next 2. So 1 plus 2 is 3. 2 plus 1 is 3. Now let's look at when n equals 4. Okay, again, 1 and 1. Okay. Now let's add our terms. And I get 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Alright, are you seeing how we're doing this? This is, we are adding the terms up to get the next cycle. Now you'll notice with each one, n equals 0, there's 1 term, n equals 1, there's 2. N equals 2, there's 3 terms, n equals 3, there's 4 terms. Alright, there's actually one more term. Ones are on the outside, you add your terms up in the middle to get the middle terms. Okay, let's go ahead and do n equals 5, just so that we can, and this keeps going on forever, actually. Okay, so 1 and 1. 1 plus 4 is 5, 4 plus 6. Okay. 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. Alright, so this would actually keep going on forever and ever. It's called Pascal's triangle. We are going to do an activity with it in a couple of days. But I want you to notice something. Okay, let's look at the coefficients for a moment of our terms. Okay, for n equals 0, we have just 1. Alright, for n equals 1, 1 and 1. Okay, 1 and 1. Okay, n equals 2. Okay, 1, 2, 1. Do you see this? Isn't this cool? I think this is really neat how this works. Okay, let's look at 3. Okay, 1, 3, 3, 1. Alright, let's look at 4. 1, 4, 6, 4, 1. Isn't that cool? Isn't that cool? Look, it follows the exact same pattern. For n equals 4, here we go here, kind of got me. Okay, it's 1, 4, 6, 4, 1. 1, 1, 4, 6, 4, 1. So if we were to write the binomial expansion out for 5, we would be able to do that using the 1, 5, 10, 5, 1. So somewhere in your notes or somewhere, you might want to just write out a Pascal's triangle for, maybe up to 10, just so you can see it. I don't remember what your homework, how far your homework went. I don't know that it went more than 9 or 8. I can't remember for sure. But the Pascal's triangle, if you have it, that way you can refer back to it. All right. So let's do 2 examples. All right. So example 1. Okay. We have this here, 2x plus 3 to the 3rd power. All right. Now I'm going to write a mini Pascal's triangle here so that I have it. Alright, so all I need is 3, right? This is n equals 0, n equals 1, 2, and 3. Okay, so I'm going to go ahead and expand this using what I know about binomial expansion. So we're going to start with that this is A and this is B. Okay, so we know our first term is going to be, our coefficient is going to be 1. So it's 2x to the 3rd power, right? Because A is 2x. Then I'm going to have my next coefficient is going to be 3. So 3, and now I have my 2x. Okay? Remember that my exponents are now going down for the A, so it's going to be 2x squared. And we're going to introduce the B term times 3. Then my next coefficient over here is 3. Let's separate this. That's not where Pascal's triangle is going to go. Okay, so 3. Now I have 2x to the first term times 3. Now let's look at this. 3 right here has a power of 1. So 3 right here is going to have a power of 2. And then my last term, my coefficient is 1. I don't have to write it up there. And my b term is 3 to the third. Now, I would like you to simplify. When we get into the binomial theorem, you don't have to simplify because they're much bigger, but with binomial expansion, we will. So 2x to the third is 8x to the third, plus, now if I simplify 3 times 3 times 2 squared, it's 36x squared. Okay, and again here, 3 times 9 times 2 is 54x plus 3 to the third, which is 27. Okay, so part of your homework will have problems that look like this. All right, they're asking you to expand, and actually that is what most of your homework is. We're going to do one that's a little bit harder now, and then I will be done with the video. I know this is a little long. Tomorrow's video will be short. The video after that will probably be even longer, about 20 minutes or so. All right, so let's look at example 2. So example 2, we have what might be considered a hard binomial. All right, raised to the 5th power. So let's do a mini Pascal's triangle for a moment. 1, A1 and 1, 1, 2, 1, 1, 3, 3, 1. Oh, we ran out of room. 1, 4, 6, 4, 1. Okay, and I had room, so we're going to go 1, 5, 10, 10, 5, 1. Okay. So let's look at our A is just x, and our B is a negative 2 over x. All right, it's very important that you put parentheses on it, otherwise the negatives won't turn out right. So this one, I'm going to go, okay, my coefficient for the first term is 1. That's always 1. So we're going to go 1 times my a to the 5th, which is x to the 5th, plus, okay. Now, my coefficient on the second term here is 5. 5. My a term, now remember the pattern, so it goes 5 and now 4. Okay, so x to the 4th. And then we introduce the b times negative 2 over x. All right, it's also to the first power. Now we're going to do the next one. My coefficient on the third term is 10. So it's 10. X is my first term. Remember now the exponents are going down. We want 5, 4, 3. Okay, times negative 2 over x. My exponents are now going up. This had a power of 1. This has a power of 2. Okay, plus my coefficient for the next term is 10. 10 times x. Remember, we're going down now, 2. Okay, and my b value is going up to the third. And I have to go on to the next line here. And for my last term, or no, I have 2 more terms. For my next to last term, I have 5. That's my coefficient. Okay. Now it's just x because this was x squared, so now it's x to the 1. And then b, negative 2x to the 4th, because I went 1, 2, 3, 4. And my last term has a coefficient of 1, and I take my b term to the 5th power, because I went 1, 2, 3, 4, 5. All right, so I hope you saw the patterns, okay? I hope you saw the patterns and you can see them. We do need to simplify this. So if I were to do all the multiplication out, right, remember that when you have parentheses around with a negative that you must put them in, especially like right here with squared, you must put them in the parentheses and then the squared on the outside. So my simplified version here is x to the 5th minus 10x to the 3rd plus 40x minus 80 over x plus 80 over x to the 3rd minus 32 over x to the 5th. And the reason these exponents on the x's are different than they are up here is because when we start having x's over other x's, they start canceling out. So, like I said, I hope you were able to follow the patterns. I tried to go very slowly, which is why the video was a little long. Go back and watch it again if you need to, or at least watch where the patterns come from. There are formulas and things in your book as well if you need extra practice. I won't make the homework too long, but you do need to double check and make sure that that you can do that. Keep in mind answers in the back of the book. There are lots of room for error. Okay, if you notice here, there was a lot of places where I could have actually screwed up. I was very proud of myself, though I did it once and then I double checked my answer and I did it right the first time. So pat yourself on the back if you can do that. Aside from that, I will see you tomorrow.